Let's take a look at probability, figure out what it is, and how we can actually find it. You can see in the notes it says probability is a number between 0 and 1. That doesn't make a lot of sense unless you actually think of that as percents. Now, probability can be written as a fraction, a decimal, or a percent, but if you think about it as percents, it makes a lot more sense. Think about 0% chance of happening means it won't happen, it's impossible, and 100% chance of happening means it's definitely going to happen. So if you hear the weatherman say, well, there's a 100% chance of rain, well, the decimal form of 100% is 1. So you can see that it's definitely going to rain. So what we do is we change our percents into decimals, and then we can place them between 0 and 1 and figure out how likely it is that something will happen. We'll get into that in a little bit, but right now let's just look at this 0 and 1 a little more. The other thing you need to remember is that the probability of something happening plus the probability of it not happening will always equal 1. Again, let me give you an example that'll make this hopefully a little clearer. You're watching TV, the weatherman comes on and he says there's a 70% chance of rain. Well, if there's a 70% chance of rain, there's also a 30% chance that it won't rain. Now the decimal form of 70% is 0.7. And the decimal form of 30% is 0.3. So if you look at this, this is 70% chance it will rain, 30% chance it won't rain, and this adds up to 100% or 1. In other words, there's a chance it might rain, there's a chance it won't rain, but we will have weather. Okay? And that's what that means when we're talking about between 0 and 1. Now, how do we find probability? Well, it's the total number of possible outcomes as a denominator, and as a numerator we write the desired outcomes. Now, this is what we mean by desired outcome. The capital P stands for probability, and in the parentheses we put what we're looking for. So if I'm looking for red, I would just write the probability of getting something that's red. If I'm rolling a dice, what's the probability of getting a 1? And I can also do things like, what's the probability of not getting a 3? Again, if I'm rolling the dice, not getting an odd number. So it's all these things that I could be looking for, and I just put that inside the parentheses. So whatever I'm looking for is what goes inside the parentheses. Now, I'll give you an example here of how to do this, but first of all, let's take a look at theoretical probability. Theoretical probability just means that I'm not going to do all of these experiments. I'm just going to look to see how many times or how many possible things can happen and how many things are there of what I want. So let's take a look at this wheel, and hopefully that'll make a little sense. Okay, theoretical probability is what might happen when trials are performed. So in other words, we're kind of making a very educated guess as to what might happen if someone actually spun this spinner a number of times. Okay, so let's take a look at this, and you can see desired outcomes over total possible outcomes. So let's look at our wheel here. How many possible outcomes do we have? Well, there's 1, 2, 3, 4, 5, 6, 7, 8. Our spinner could land in 8 places. Okay? And then how many violets are there? So the probability of violet, and that's how you would write that. So how many violets are there? Well, there's 1. So my probability of having a spinner land on violet, theoretically, would be 1 out of 8, which is 0.125, or if you remember how to change that into a percent, 12.5%. Okay? Could happen. Okay, the second type of probability is called experimental probability, and that's when you actually do the experiments over and over. So you can see in this one, it says Alex rolled the dice 12 times. He's actually rolling the dice. He noticed that 3 of his rolls were 4s. What was the experimental probability of rolling a 4? So, again, it's the total number of attempts this time in experimental probability. So he tried 12 times, and he rolled a 4 3 times. So 3 out of 12 is 1/4, which is 0.25, which again comes between 0 and 1, and that's 25%. Now this would change over time. The more you do it, the more theoretical and experimental come closer together. But sometimes when you just do it a few times, there can be a big difference between the two. But that's how you do experimental probability. It's the total number of attempts as a denominator and how many times you got what you wanted. Remember again, the probability of what was your event? 4s. So when you do experimental probability, it is what actually happens when trials are performed. Okay, let's take a look and see if we can identify the difference between theoretical and experimental. The probability of rolling a 3 on a dice is 1 out of 8. I don't know if you can see that, but it does says 1 out of 8. Nope, should be 1 out of 6. I apologize. It's a dice, isn't it? There's 6 possible outcomes on a dice. 1, 2, 3, 4, 5, 6. So 1 out of 6. Okay, did we actually throw the dice? No. We counted out how many outcomes that were possible over what we wanted. We wanted the probability of 3. So this is theoretical. I'll just abbreviate it there. Okay, second one. I flipped a coin 20 times. Well, I actually flipped the coin according to this, so this is experimental. Remember, if you're actually doing the experiment, that's experimental. There were 15 boys and 20 girls in a room. The probability of randomly choosing a boy is 3 out of 7. Did I actually go in and choose any people out of the room? No, this is just theoretical. And then finally, Frankie reached in a bag and picked a marble 20 times and got a green marble 5 times. He's reaching into the bag. He's doing it. This is experimental. Okay? So you can see that when you're actually doing something, that's experimental. When you're just counting how many possible outcomes, that's theoretical. Finally, let's figure out some probabilities of what we're looking for. Over here, we're looking at the first one where it says, what's the probability of getting a red fish? Well, again, we're going to see how many possible outcomes there are. So there's 3 red, 7 blue. That's 10. And 9 green, so that's 19. What's the probability of picking a red fish? Well, how many red are there? There's 3. Any one of those 3 would satisfy what I'm looking for. So the probability of getting a red fish would be 3 out of 19. And you remember we can change that into a decimal or a percent. Let's look at the next one. In a bag of marbles, there are 8 orange, 7 purple, and 5 gold marbles. So again, how many total marbles? You got 15, 20 total marbles. We're looking for gold ones. How many gold ones are there? 5. So the probability of getting a gold one is 5 out of 20, which is 1/4. And again, we can change that to 0.25, 25 hundredths, or 25%. And finally, this one. Take a look at this one now. It says not coconut. Okay, so we're looking for anything that's not coconut. Okay, a box of 20 chocolates has 3 pieces that contain coconut. So there's 20 total pieces, but remember, if 3 pieces have coconut, 17 of them don't. And we're looking for the ones that don't have coconut, so your probability would be 17 out of 20. And again, change it to a decimal. You'll find it falls between 0 and 1, or you can write it as a percent.